Now this is going to be a big scale of what we've done so far. Let's see whether you can remember. This is called sodium carbonate, and sodium carbonate has the formula of Na2CO3, okay, sodium carbonate. And you'll find that this sodium carbonate, when dissolved in water, let's put some water inside. All sodium compound will be soluble. Okay, so we put some more sodium carbonate. And shake it a bit. Yeah. Okay, we're going to put in universal indicator. And immediately you find that the universal indicator, which is actually green when it's provided, turns what? Purple, okay. It turns purple. Now, this also can be called violet. I don't know, some people, the violet is a little bit red, but this is purple. Okay? Now let's see what happens if we add some vinegar to it. I will add some vinegar from here, which is called ethanoic acid. And if I add the vinegar in, you find that that purple color will change as they react with the vinegar. And what do you have? What did you see? The purple color becomes green. Is it green? Okay, let's see. Let's put in. So it becomes green. Huh? Yes, it becomes green. Maybe if we switch off this light, it might be a better green color. Huh? So let's put some more vinegar. This is 20% ethanoic acid, so maybe that's a little bit concentrated, but never mind. Let's put in a little bit. Oh, now certain parts become what? Reddish, right? Huh? Certain parts become reddish. Let's put more UI into it, and you'll find that this one becomes red. Okay? Actually, it also becomes a little bit orangey, right? Is it a little bit orange? Is it a bit orange? Let's put some more. That's a lot, that's a lot. That's a lot of vinegar. Okay. That's a lot of vinegar. Now the vinegar will react with sodium carbonate. All carbonate will give you carbon dioxide. Okay? So we add some more vinegar. And slowly drip it in. And you find that the gray color immediately appears. Okay? So this red color appears. And what have we got? What other colors do you think you can see? What other colors do you think? Can you see green? Can you see green? Is it green? Is there green between the purple and the red? Is there green here? There is, right? Huh? Now, when there is green there in the middle portion, there is also a little bit of yellow, right? Do you see a bit of yellow? Huh? Okay. Now let's pour some more acid in. Huh? Oh, this here. Okay. Let's pour some more acid in. So what have we got? We have got green, and we are going to get some yellow. I think if you look carefully between the green and the red, you might be able to see some yellow. You think you can see some yellow? Can? Not very clear. Let's try that and see. No. Come on, come on, come on, come on, come on, come on. Come on, come on. Now the yellow is beginning to appear. A little bit, but not so much. Let's try that again. Is it beginning to appear? No. Is the yellow beginning to appear? Yes, sir. It's beginning to appear. Okay, the yellow is beginning to appear. Let's put it here for a little while. Let me show you what I've done with the small test. This is what I've done here. Small test tube. Let's put on this camera. Okay. Oh! Can you see this one? Can you see there's yellow? There's yellow, there is between the green, yellow, there's also orange color. Okay, so if we leave this long enough, the yellow will begin to appear. Maybe we will look at it at the end of the other experiment. And the other experiment has also something to do with vinegar. Okay, let's put this by the side. Let's put this here. Okay. Now, what is this?
Egg.
This is a raw egg, right? This is a raw egg. And then I put some water. And then the egg, when it is fresh, it will sink in water and vinegar. Can you see right now? the egg is sunken, right? That means it's denser than vinegar. Okay, so let's put more vinegar, and as I put more vinegar, what can you see at the surface of the egg?
Bubbles.
Bubbles, yeah. Now, if I were to tell you that the egg contains a carbonate, and just now when we reacted the carbonate with the acid, it also gave bubbles, right? Huh? Now this bubble is actually carbon dioxide. The carbon dioxide that we blow out when we breathe out. Okay? And now you can see the bubbles are sticking onto it, right? Now if the bubble sticks onto it, what do you think will happen to the egg? Will it rise to the surface? You see the egg? Huh? You remember last time when we put raisins in the aerated water? So you can see now this has got so much bubbles. Huh? Alright, let's give it a little bit of stir and see. So the eggshell actually reacts with the vinegar. Now it's beginning to rise, right? Can you see it rising? It's not touching the bottom anymore, right? Is it touching the bottom? Maybe a little bit, okay. Let's put a little bit more vinegar. And vinegar smells like what? Smells like vinegar. Okay, now we're going to smell vinegar. Take out your mask. Vinegar smells sour, right? Yeah. It is actually quite difficult to explain why vinegar smells sour at this level. But we'll explain it by and by, okay? We'll explain it by and by. So now, can you see now? This one is beginning to rise. Let's put more vinegar and let it rise. Oh, it's about to rise. And of course, vinegar is acidic. And if it's acidic, we put a little bit of UI. What color will it get? What color? Red. So I put a little bit. Can you see? It's red in color. Oh, red. There you are. Now you know what will happen if I put this for 3 hours. But then we don't have 3 hours. We have only 1.5 hours. So before you came yesterday, I put the egg inside vinegar whole day. And you know what happened? This is what happened here. Or this one. Can you see this egg? And this egg has become very soft and there is no shell. Give me your hand. Of course, this egg has become so soft that if I were to let it fall onto this surface, it will bounce. Well, huh? It will bounce. Okay, I know only did one, but I did another 2 here. And this one will also bounce. And this one will also bounce. So cute. You see? Bounce. Okay. So it bounce here, and it can also bounce here. Okay. So this is what happens when all the hard shell are removed. Okay? When all the hard shell are removed. Let's dry this. Let's dry the surface. And then we shall let you take one home to show your mother and your father and your sister an egg without a shell. Egg without a shell. Okay. After we'll let you take back. And we want to know exactly what happened from here with the shell to here without the shell. The process of the chicken and the duck producing the egg is a very complicated process. And of course, we will need carbon dioxide to go into here to make an insoluble calcium carbonate. Okay, right, there you are. Good. Good. Now let's leave this aside. Leave this aside. And now let's go back to our this. And now can you see a little bit of yellow between the green and the red? Can you see a bit of yellow? Now what is actually happening here is the red portion means that there are a lot of hydrogen ions, and hydrogen ion tastes sour. Okay? Then as you go down, the hydrogen ion becomes less and less, and it turns to orange, and it turns to yellow. And when you reach the green portion, here, the green portion, you will find that the green portion has equal number of hydrogen ion and hydroxyl ion. Hydroxyl ion is the one that makes it alkaline. Okay? So when the number of hydroxyl ion and the number of hydrogen ions are equal, and we are talking about millions and millions and millions and millions of ions, then the UI will become green again. The UI will become green. And then the purple section at the bottom means that there are more hydroxyl ions than hydrogen ion. And I think the world is needing hydrogen ions and hydroxyl ions to make a liquid called hydrogen ion plus hydroxyl ion. You will make a liquid called, you drink it every day, called water. Yeah, that's right. Water is so very important. And then they usually say, if you can find water in the planet, there usually will be life there. Okay, so this is rainbow in the test tube. This is rainbow in the test tube, and that is a soft shell egg. that can bounce. Okay, bounce. Yeah, I suppose you cannot drop it for too high right now. Maybe up to here. Then you still won't break. Okay, this will be given to your mother to see an egg without a shell. Okay, let me get a container. Let me get a container first. So put this egg inside here, and then we use cling wrap. No, not cling wrap. We use a cover. I think this one can cover, cannot cover. This one cannot cover. Ah, I got no more cover. Never mind. We will use cling wrap to cover that. Okay. And then you can bring it back to show your mom. Okay, that's enough for today. And we will now do the